Well, welcome everyone. This is another exciting Learning Lab. This is Learning Lab number 57, and we're going to be talking some energy forecasting, and this is part of our Targets in Production series. And I do have a special guest with me. Will, if you wouldn't mind saying hello to everybody.
Hi, everyone. Matt, thank you for bringing me on, and I'm really excited to be here.
I'm excited to have you. I've been following Targets here for quite a bit, and this has been really exciting being able to combine my love of forecasting also with your new tools that really just make doing analysis a joy from a reproducibility and also from an efficiency standpoint. So I'm really excited to have you, Will, and thanks so much for joining us. All right, so to get started here, we're going to be doing some energy forecasting today. Again, I have Will with me. The goals for today, we're going to be learning a little bit more about targets. So last week or 2 weeks ago, we had Lab 56, and that was kind of an introduction to the targets package. So our goal from today is going to be to extend that a little bit further now. And we're going to be talking about a nice topic that's really powerful. It's called branching, which is great for scaling our analysis for long-running computations. And basically what we're going to do is extend targets now so we can build a production pipeline for forecasting and reporting with Modeltime. And here's an example of the forecast report. This is the data product that we're going to generate from all of our forecasts. And what this will do is it'll showcase the value of being able to visualize all the forecasts, being able to produce the report through an extension of targets called Tarchetypes. And what we'll be doing is also highlighting any errors. So this is actually an audit report of our forecasting system. It will be helpful if you've attended Lab 56. If you haven't, don't worry, you'll still be able to follow along, but Lab 56 goes through some of that introductory material. Also, it will be helpful if you've had some functional programming experience. So for any of my students, if you've taken the 101 course, you're going to be perfectly fine. But if you've never built a function in R before, then some things may look a little complicated. With that said, this is going to be very fun. This is the workflow that we're going to be doing today. And I will tell you what, Will, when I started, so I've been forecasting with Modeltime. I built Modeltime to help save me some code as I'm producing my forecasts and help to be able to integrate kind of like the tidy models infrastructure. Well, the problem with doing just a normal forecasting kind of iteration, and this is what targets solved for me, and I recognize this now, is that every time that I run through my analysis and make like a small change here, or maybe I add a new model, and this is what Modeltime does really well, is it kind of keeps track of all your models, but I have to rerun all of those models again. What Targets does is it kind of locates the areas that don't need to be run again in my code, and it allows me to skip those steps and do things very, very efficiently. And this is kind of what I hope to highlight today with some of the branching techniques. So the workflow we're going to be doing is taking our forecast, going in through applying targets, and then creating a forecast audit report. So I'm super excited about this. Just real quick, if you are just now, if this is your first Learning Lab, this lab goes into Learning Labs Pro. Learning Labs Pro is a paid service, but it's a really awesome thing. You subscribe to it, you get access to all of the previous labs, so Lab 56 that I was talking about, and then all of the previous labs, so over 50 labs on all sorts of powerful topics. I'll put this link into the chat for any of you who want to check that out. And you guys are more than welcome to join up in Learning Labs Pro. So I just put that into the chat. Also, what I do as part of Learning Labs Pro, I give away lots of bonuses. So these are a few of the shiny apps that I've given away in the past several labs. And then also today, our bonus for today is the forecast summary report, which is an automated report that Targets will produce for us. You guys get that for joining in Learning Labs Pro. All right. So Will, I want to talk with you. I want to get to know you a little bit better. on live on our live learning lab. I hope that's okay. And I want to find out, kind of some of the motivations with your software development and how you got into this. So let's talk about you as in your progression as a data scientist and how you came to develop targets and where that kind of fits in your in just you becoming a software developer. So would you mind talking about that for me?
Sure, I'd be happy to. So, throughout my education, I've always been into math and computer science and the STEM fields in general. Got into statistics because I wanted a better understanding of the scientific process. I really enjoyed coding day to day. And I think that set me up to do a lot of really interesting work. And in grad school was one of the motivations that originally spurred me on to write Targets. Well, Drake before then, but Targets is now the successor. I was, for my dissertation work, I was working on this genomics model that was this Bayesian genomics model that had super long runtimes. I did my best to follow software development and reproducibility best practices. But when it actually came to running some simulation studies and some studies on real data sets, I was having this problem where I would deploy some work to the cluster, and then I would realize that I had a problem with my code, or the data simulation algorithm needed an update. And it was this constant back and forth of spending hours and hours waiting for things in the cluster to finish and making very small, very, very easy changes to make on my end. The trouble is that there was a hidden cost with all those changes. The downstream results need to be updated. And that cost for me became highly non-trivial. And I saw this as a problem that the R community didn't at the time. I saw similar problems across Bayesian statistics because we deal with Markov chain Monte Carlo, big expensive computation, but not a whole lot of tools or acknowledgement of the problem that would lead to the creation of those tools. So I thought this is a problem I care about a lot. It's affecting how I do my work, and it looks like a really interesting kind of tool to develop. So starting at the very end of grad school, I wrote extension packages to the predecessor of Drake, which is called Remake. It's a great package by Rich Fitzjohn, and by the time I ended up writing those extensions to Remake, Rich had already moved on to other projects. He had changed jobs. He was no longer interested in maintaining it, which is part of the reason why I created Drake and then Targets. And it's been a joy to work on these pipeline tools. It's some of the most gratifying work that I've ever done, and I haven't looked back since.
So, wow, that's exciting. So you basically had this issue kind of in grad school and through your career progression, and then you've been able to somehow tackle one of probably the most complicated things yourself, which I know let's talk about Python a little bit too. Python has a bunch of these tools that are out there. Probably one of the most popular is Airflow, which is made by the folks at Airbnb. So I always think of these kind of pipeline tools, and I'm thinking, normally there's a big company associated. It's not just one person who had a problem, but like this, and that always seems kind of like a monolithic thing, right? Where you've got, you're trying to come up with a whole system of tracking changes, of being able to reproduce analyses, of being able to parallel process, being able to do these new things like branching. That is just kind of insane to me. I don't know how you must, you must live for this stuff.
So I take a lot of working on this gives me joy, and I love to think about these problems. I love to do this stuff. But even more than that, instead of having a big company behind this, there's a big community behind it. The R community is always, there's drive-by questions, drive-by curiosity from data scientists from the other side of the world who are curious and who just happen to find what I'm working on and ask questions and suggest ideas. And it still blows my mind how connected the open source community in general can be, and what a fountain of ideas it always is. And connecting with ROpenSci was another major boost. Connected me with ROpenSci granted me access to the best developers in the R community, and they've opened my eyes. Drake and Targets would not be what they are today without the support of people like them. I mean, the ideas for branching actually originally came from Kirill Mueller, who's the maintainer of Tibble and other tidyverse packages. Yeah, and we were talking at the RStudio Conf. I met him at RStudio Conf 2018, and he proposed all kinds of ideas for high performance computing and what he called a tidyverse extension, or tidyverse DSL, on top of Targets, which became on top of Drake at the time, which became static branching, which became dynamic branching. Nice. I wouldn't have thought that was a thing. What I was trying on my own was a text-based wildcard manipulation system similar to Glue before then. And he opened my eyes to what's possible in terms of metaprogramming, and also in terms of the need for dynamic branching, where you don't necessarily know which targets or even how many targets you're going to have before you get the actual pipeline going.
Right. Oh my gosh. Wow. That's crazy. So Kirill, I mean, also a monster in the R space and R community. And I'm glad you brought up too, ROpenSci. I mean, I think, and I honestly, I don't know enough about ROpenSci, but how did you get linked up with them?
So I actually heard Hillary Parker mention it on the Not So Standard Deviations podcast in relation to Rich Fitzjohn's work. And I thought, wow, what a great place to submit this work to. What a great group of people to collaborate with. There was that common interest that we had, and I submitted Drake for a software review, and that went amazingly well. And I got great feedback, mostly on the documentation and use cases, under basically conveying the problem that Drake was trying to solve for a general audience. I'm still learning that skill, and that's how it started. And they've been a fantastic group of people dedicated to expanding the tool ecosystem for reproducible research and open data and open science. And nice. They branch out to other communities like our studio, et cetera, all over the open source community. And yeah, I've benefited tremendously, and so is my work.
Good. Well, it sounds like they're giving you a lot of resources and a lot of help along the way. So for all of my students and for everyone on the call today, I mean, it's what Will's saying is definitely true. You know, the RStats community, whether it's on Twitter or whether it's, you know, through ROpenSci, something more formal like that, or our studio, the company that's out there. It's just a welcoming community, and it's a bunch of very passionate people. I've experienced the same thing, Will. So, you know, from my initial upbringing, which was kind of like my initial package that I will say got a little bit of traction was TidyQuant. And I released that, this was back in 2016. And this was before I even really knew much about the R community. And how mine kind of took off was like you have ROpenSci. I had Hadley Wickham during, I think it was the 2017 RStudio conference. He mentioned it in the keynote, and you know, it was like off to the races after that, because people just started scooping it up left and right and downloading it. And you know, it's funny, but like that community aspect is really how kind of what brings everyone together, in my opinion. So very cool, man. I'm really, really appreciative of all the work that you're doing. Let's talk a little bit about kind of your background. I know what's cool is I think you bring a different kind of aspect to data science. One of the things that you're heavily involved in is Bayesian. Can you talk a little bit about kind of maybe your background a little bit, just so people know where you're coming from?
Sure. So my training is in statistics. I mean, not everybody who comes to the art community has taken a whole lot of coursework in statistics, but that's where my background originally comes from, traditional master's and then PhD program. At Iowa State, my advisor was Jared Niemi, and I worked a lot in Dan Nettleton's NextGen sequencing data analysis group at Iowa State. Also peripherally involved with, to some extent, I was following the statistical graphics group with Di Cook and Heike Hoffman when Dr. Cook was still there, and yeah, so those are sort of the groups and people who I worked with. I took a Bayesian methods class with Jared, and I thought, okay, if I can work with him, because of the way he teaches and how I want to soak up what he has to say.
So you're talking about Jared Lander, right?
Jared Niemi. Actually.
Oh, Jared Niemi.
Yeah.
Okay.
So I've worked with I've talked with Jared Lander as well. This is a different Jared though.
Well, I know Jared Lander's a big fan of your work too. I see him talking about targets a lot on Twitter. But
tremendous advocate.
Different Jareds. Okay.
Yeah. So and so Jared and Dan brought to me this. They were working on this project that combined, GPU computing and hierarchical models and genomics data, and it took persistence to make progress on that problem, but it was still an interesting problem. So we had a large hierarchical Bayesian model for this crop heterosis problem in genomics. So if you breed together two different lines of maize, in phenotypically, you notice the hybrid varieties are usually they usually grow taller, they have better yield, they have better disease resistance. And we were starting to look at, okay, well, do some of those same things translate to the genomic level? And so we applied those same concepts to how we were preparing hierarchical models for genomics data sets. And the computational aspect of this is interesting because there's no way you could throw Stan at a problem like this at the time. I mean, Stan's gotten faster. Nothing against Stan. Stan is amazing, but this was just such a massive model that where Stan and JAGS and other sort of black box frameworks for modeling were at the time. I kind of want to actually try Stan again now that it's been several years of improvements, but
it'll still heat your computer up if you run it. It'll still heat your computer.
It's been keeping. Yes, I believe that. But at the time, we were struggling to use all these black box computing software tools to fit this model. So what I ended up doing for my dissertation project is creating a custom Markov chain Monte Carlo algorithm. It was a slice sampler within Gibbs algorithm that used GPU computing. So I was programming in CUDA C to implement this. It's a very heavy use of a couple of very simple aspects of CUDA to parallelize Gibbs steps across GPU threads univariately. And even with that, so that ended up actually making this model tractable relative to just programming it in C. The going from running on a CPU to running on a GPU, it turned hours into days. And if I hadn't sort of done a custom implementation in C, it probably would have taken a lot longer. But it was still 4 hours long, even with a GPU, to fit a single model to a single data set. And my dissertation required 20 or 30 data sets to be fit to do a reasonable simulation study and to analyze some real data sets. So that added up to a lot of runtime.
Right. So parallelization became pretty important, I would imagine.
Parallelization on the GPU, and I would have really benefited from being able to run models in parallel with a tool like Targets, a pipeline tool. I didn't have that at the time. I didn't have the computing resources that I do now, but and I didn't have, and black box MCMC tools have gotten a whole lot better too. So I believe Stan has GPU support for certain things now, like Cholesky factorization and things like that. But I focused almost exclusively on parallelism within the algorithm and didn't really have a whole lot of options for parallelizing among different models. And I think targets itself focuses on the latter parallelism where you have sort of parallelizing the steps of an overall workflow.
Yes. Yeah, no, it's really cool what you've done with targets and to be able to do the parallelization so easily. I will try and check that out. I'll try and do that. I wanted to do that for this lab, but I actually ran it all in series, just because the skipping of the steps was actually just enough of a performance boost for this particular lab.
And it's usually that hard to. I don't really teach in the workshops that I give on targets. I seldom teach parallel computing because targets just makes it really easy for most of the time. There's a little bit of setup when it comes to running things on clusters. But all you really have to do is choose either tar make cluster MQ or tar make future and choose the number of workers and choose a backend for future or cluster MQ. And targets figures out everything else, which steps can run in parallel and which steps need to wait for upstream dependencies in order to start.
Well, I'll tell you what, maybe on this lab, once we get into the code, we can try it. If you're up for it.
Sure.
We can see we can get it from the master, and we'll get it going. All right. Well, thank you so much, Will. I wanted to just real quick. I want to send everyone this link to the targets manual. We're going to be relying. I relied very heavily on these on this particular book that you put together. So it's called the Targets User Manual. It's really, in my opinion, it's a book because it really goes through all of the different components of targets, almost as like hey, this is the workflow. These are things that you're going to need to run into. These are, this is how you debug. This is how you do the branching. And as I was building the lab, so this one for today and the one for 2 weeks ago, I basically was able to kind of go through the first section for the first learning lab, and then the back half of the book for the second one. So talking about things like the parallel processing, the dynamic and static branching. So kudos you, man. This thing is amazing. It covers every possible aspect that I needed to develop these two labs, and it really made it simple to get up to speed. I don't know if you guys know the behind the scenes, what goes into these learning labs. It's usually I've gotten it down to about a day and a half of work. And it's because people like Will put together these awesome training resources that allow me to get up to speed that quickly. So I usually only schedule, for the code about half of a day worth of work. And I was able to do it with your book, Will.
Really glad to hear it. Thank you so much.
I appreciate it. All right, so let's talk real quick about the business problem. So this is a forecasting problem. We have, it's actually kind of it's the same data set that we used in lab 54, which was where we used we built a couple of XGBoost models to model energy prices, or not energy prices, but energy demand usage in the US. So you see here that we've got different time series. This first one is kind of a collective time series of so it's a hierarchical data set, where this one is the additive of all of these different fuel sources here. So that's this time series is just the basic addition of all of these other 17 time series. So it looks pretty flat, but it does definitely have a seasonality to it. And but what's interesting is when you break this apart into each of the different fuels, you can kind of see these different trends that are going on. So we decided to model it in lab 54 with XGBoost, which is where you build one model, one XGBoost model, and it produces all 18 of these. So Will, this is a scalable, it's kind of a newer technique that they've been doing in Kaggle competitions. And it's really, really powerful because the problem that you run in with time series is normally you're talking like ARIMA models, and this is what everyone uses, but you have to loop through every single time series. The problem, with 18 time series, it's not that bad, But once you get up to, like 10,000 time series, which is what many businesses are dealing with today with when you have customer data, and you want to like forecast all of your different customers or products data, you want to forecast demand for all of your products, it becomes really super expensive. So one technique is to use what's called a global model, and that's like XGBoost, what we did in Lab 54, where one model produces the forecast for all of these. The problem with global models is while they're much more efficient, they can be less accurate, although XGBoost still does a pretty good job. But it's tough to beat, if you want to run like ARIMA and profit on all 18 of these models, generally, and picking the best local model. So this is what I call a local model. We're building one model for each of these different time series, and we're having to loop through. So that's what we're going to do today. That's the expensive way to do it, but it can give you higher accuracy. And I'm going to show how you can do it with targets today. So that's going to be what we're tackling: localized model forecasting at scale with model time and targets. The workflow, we've already kind of talked about this. Basically, what we're going to do is integrate forecasting with targets. Targets allows us to track all of the information, skipping the steps, the expensive steps that have already run. And we're going to see this because when we add a model, we won't need to rerun all the steps. We'll only need to run the steps that are important to that specific model, which makes this kind of workflow of building a forecasting system much, much faster and more scalable. And we'll end with a data product. So that data product today is going to be our forecast audit. That's the bonus that we're giving out. The way that audit works, so this is what the audit is. It's going to produce plots of all of our different forecasts. It's going to give the forecast accuracy table that's tracked. And this is basically just metadata that targets tracks for us. We get this for free. Well, all we need to do is build the function to produce it, and then targets will track it for us. And then what's really cool is then we'll also have some error auditing. So this is going to report, any issues that we have. And this one on the training data set, it's telling me that there was an R squared of less than 0.15. So prediction has low variance, and I need to look into this target group. So how I would use this, I would take a look at that prediction, that model number 5, and I would zoom in on this and kind of see what happened. And then what I'm seeing here is when I look at it, the forecast still looks pretty good. So that's great that it highlighted it, flagged it, but it doesn't look like there's really any issues. And I see that there was a big drop here, which is probably why that forecast on the test set was not so good, because I don't see that big drop. That spike was not probably in the training data. So it's kind of an auditing tool. So it gives me a way to check this out. This is pretty much what every business wants. They want to be able to produce a lot of forecasts, and they want to know when things are going wrong. That's what this report does. So we're going to see how model time and targets can combine also with our Markdown to do this. Okay, so again, that's the bonus. Just to summarize, everything is tracked with this reporting system. We're going to skip steps that don't need to be run. Thank you to targets. And it's going to automate the reporting for us using the Tarchetypes package. Why targets? So we've already kind of been talking a little bit about this, but targets, to me, it's a big efficiency booster. So it allows us to track everything, but it also allows us to skip expensive steps. And then we can do some cool things like parallelization, and also it connects with the cloud. Is that correct, Will? You've added some function.
So that's in its beginning stages, actually. So it currently can upload the files on a target by target basis to the cloud. It keeps metadata local. And the pattern that I envisioned for that was to keep the metadata and all the lightweight targets local and under version control through Git or GitHub deployed with the tracked with the source. And then all your really big data sets would go to the cloud. Ones that are too big for version control.
Right.
There are a bunch of alternatives that I'm exploring. I'm just getting into the cloud computing space, honestly, because of the resources that I personally have available. My company's getting into it a bit more, which helps. But then there are the backend technologies for parallelizing, like Future and ClusterMQ. I'm talking with the maintainers of those packages, and we're working on actually being able to compute on things like Lambda. But that is a limitation of the R community in general, and it's only a matter of time before that becomes available to targets.
Well, and I will tell you this too. You should check out if you have, I mean, you probably have Metaflow, which we did actually a learning lab on. We did a production series a while back. And the guys at Metaflow actually helped me with it. Their Metaflow is produced by Netflix. Netflix is the maintainer, and they were super helpful. And they do a ton with like AWS Batch, and honestly, if that's the direction that you're looking to take targets, they'll probably help you out with it.
Yeah, and they have, and we've discussed. They're super nice people and really helpful, and we've discussed some of this. I borrowed actually the way AWS S3 storage works in targets. I borrowed from them.
Nice. Okay.
Yeah, they have a Metaflow sandbox you can try out,
Yep.
and on some example stuff. And I tried their one of their R examples on that sandbox, and I thought, okay, so there's a storage piece of this, and there's a compute piece of this. Let me tackle a storage piece of this because that's what's possible in R right now. And yeah, still working on the compute because I rely on pre-built R packages. I mean, Metaflow is willing to go really deep into the weeds to get AWS cloud compute specifically to work, super tightly integrated really nicely. Targets, the design philosophy is a little bit more hands-off. I like to build on packages that already have a bunch of this abstracted.
Right.
There's some trade-offs. Cloud compute isn't immediately available in targets, but I'm willing to be patient about that.
It'll come as the ecosystem evolves. I'm sure it'll come probably sooner than later. All right, targets. Real quick about the philosophy, and I stole this from one of your slides. I love this slide though. It succinctly tells me exactly what targets is about. Why would you want to use targets? It's when you want to scale up when you need to, skip the steps that you don't need to, and then see evidence of reproducibility. I think that this is exactly what many data scientists can benefit from, and they don't even know it. I think that's the biggest thing is they probably haven't explored targets, or they don't even know targets exist because they don't realize that they have this problem. But what I show you guys today, it'll hopefully highlight this for you. So that way you understand, okay, this is something I need to check out today. All right. And then real quick, what our focus today is on branching. This is a specific portion that comes from chapter 7 of the book. And I actually want to give that to everyone here as a link. So I'm going to post this in the chat real quick. But this is specifically what we're going to be focused on today, which is the concept called dynamic branching. Will, would you mind explaining to the folks what dynamic branching is?
Sure. Dynamic branching is a way to define targets, define new targets while the pipeline is in the middle of running. So as opposed to declaring each individual target in advance upfront and then running the pipeline. So if you have, let's say, a function that downloads a data set and then pre-processes it, and you don't already know what's in the data, but let's say you want to iterate over the data set and have a target that groups by region or that groups by some other variable in the data set, then you can use dynamic branching to create different targets based on different row groups.
Perfect. We'll actually see an example today. We're going to be actually using this function tar group by, which allows you to set up these branches. And as Will was saying, it automatically, kind of on the fly, builds these targets for us. What it allows us to do is basically iteration. So I view it as kind of like map reduce. We'll talk a little bit about that, but that's kind of how I thought about it in my mind. And it allows us to basically do things at scale, a lot of iteration. We're also going to be checking out Tarchetypes, which is also kind of how like the Modeltime ecosystem is expanding. We've got different packages now. Will, your targets package is now an ecosystem, right? So you've got several packages out there and more that I need to check out, but Tarchetypes has been really useful in development of this particular lab.
Yeah, so it's that was one of the features of targets. The extensibility relative to Drake is that because of the infrastructure and the interface and the decentralization of both of those components, it allows for these add-on targets, not only Tarchetypes, but also, so I've been developing on top of some Bayesian frameworks that I use quite a lot. So Stan, despite what I said at the beginning, did not mean to offend any Stan maintainers. I love working with them, but Stan is one of my favorite Bayesian black box tools. I use it all the time for work. I use it all the time to develop longitudinal models jointly with my colleagues. And Stan Targets is another extension package that is built on top of Targets specifically for Bayesian workflows. And one of the reasons I was excited to jump on the call today is because Tidy Models has been on my mind as well. And what would it really take to build an extension package on top of Tidy Models? Because Tidy Models has its own ideas about workflows, and I do want both systems to be compatible. Just in the initial stage of wrapping my head around it, and I'm excited by the work you've done to pilot this, because I think
you're going to see it.
Yeah, I think it could turn into an extension package like this, where it looks like maybe you're defining a targets pipeline, and you eventually the end goal is to create a function or one or more functions that make it look like you're defining just one target, but it'll give you a whole DAG of targets with one declaration that looks like it's just one target.
Exactly. Yeah. No, I would love to help out with that too. I want to see like a model time targets kind of package that kind of wraps up some of these scalability components. The problem that many data scientists are facing that I need to figure out is basically, it's very simple: how to run ARIMA in a loop. We're going to do that today with targets, but we need to think of tools that can really do this scalability piece at a much better level. And I think that's where targets comes into play. Cool. All right. So let's get started with this thing. I want to pull up the code. This is what the end goal is today. We're going to be building this. So if you guys can see my code session here, this is a big workflow where we're going to be doing lots of fun stuff. We're going to end up with a report. We're going to start by ingesting some data, some energy data, and then we're going to go through this process of kind of taking that energy data, splitting it up into future data, prepared data, and then these two paths kind of follow the same path up until right here. And then we're going to be working with our data prepared, splitting it up, creating multiple models and a RIMA model. And we see 18 branches here. So this is what we're talking about when we talk about like that tar group by. And the branching, we're making 18 branches, one for each of our 18 time series, and we're running ARIMA models on each one of them. And then we're computing the accuracy, and we're also doing it with profit. And then we're going to bring them all together, figure out what the best accuracy is, select off some best models for each of our 18 branches, refit those model, make a final forecast, do some checks, and then we're going to produce a report out of it. So that's at a high level what we're going to do, but I don't want to just jump right into that. There's a kind of a training system that I want to go through today. So for my LL Pro members, this is the data. This is all of the files that you're going to be getting with the Lab 57. The main thing that we need to talk about, so there's data, there's some functions. We'll talk about that here in a second. And there's reports. We'll talk about that here in a little bit. But there's two different modules to this talk today. There's a basic branching one, which we'll go through first, and we'll go through this pretty quickly, but it kind of introduces you to the concept of branching, which can be, Will and I were talking a little bit before this lab, and we're like, yeah, branching can be kind of a challenging aspect for people to think about. So I want to go through this basics, and hopefully with Will being also on the call, we can kind of explain some of the nuances with what branching is and showcase a kind of a simpler example before we jump into the energy forecast. Then what we're going to do is we're going to be doing this energy forecast, and this is hardcore. I mean, hardcore in a good way, right? We've got full, tons of different steps, and I want to kind of talk through how easy it is, and I want to basically focus on what the issues that targets helps us with, not necessarily understanding all the mechanics, because when you join Learning Labs Pro and get the code, you're going to be able to kind of review this on your own. So developing the code is one thing, but just understanding kind of the situations where you can use targets, I think that's going to help a lot more than really diving into some of the nuances of how to make a function and how to do that sort of thing. So we'll go through this, but it's really just extending the basics of what we're going to learn in this module here. So let's get started here with this first one. What I'm going to do, so the way these files are set up, this is the first module. We're going to be splitting it up into two sections. There's processing targets, and then there's the actual targets file. So if we remember from 2 weeks ago, you need to have this underscore targets.r file. I'm actually going to just delete out everything that's in here real quick. So I have an empty targets file. So if I run tar make on it, it's not going to really do anything. And if I look at my tar viz network, which is the main function for diagnosing issues, we get a blank chart. That's because it's reading this file underscore targets.r. It's not seeing anything in there. And that's, what we want to have happen right now because we don't have anything. So the second section is this targets file. So I'm going to copy this section here, just copy it, and I'm going to paste it right over here. So just paste it. And what this does is it gives me all of the steps that we're going to run through. So the way this targets file is set up, and this is the format, I'm loading in one library called targets, another library called Tarchetypes. We're using this tar set option set, and this is going to load packages. And think about it like this. You need to have certain packages that targets recognizes in order to be able to process your data, use any functions that you're using. So we're going to be using functions down here like LM, to make a quick linear regression and so on. And you want to be able to use any of the type of functions. So some of the functions come from Broom, for example. Down here, we're going to be using Broom tidy, which is basically a way to kind of convert certain pieces of a linear model to a data frame. So you can actually view like things like accuracy and that sort of thing. So let's check this out. What I'm going to do is just kind of step down through it. So I'm just going to do Control-Shift-C here. So we only have one target in here, and that's just going to be, I have a name of this target called mpg underscore data. And the command is it's pulling in this mpg data set. So if I just take a quick look at what mpg is, it's just kind of a toy data set that comes with the ggplot2 package. And because we're loading in tidyverse, it's going to be able to get pulled in here. Let me just run this Control-Shift-C. If I save this and go back to my branching basics, if I run tar make now, and if I do tar viz network, so we can see that we're getting some diagnostics down here. We're doing a viz network, and we now see we have MPG. So I can check out this MPG data by using a function called tar read. So if I do tar read with the name mpg underscore data, you can see what targets is doing is it's starting to track this information. So it now knows this step is reading in some data for me. So that's what this target step does. It just reads in that command, which is tells it to pull in the MPG data set. Okay, so it's not super interesting quite yet, but it will get more interesting here in a second because we're going to be doing this mapping, this idea of branching, and this idea of basically taking our data set. So if we take a look at this data set here, it's got this manufacturer column, and say I wanted to come up with a different linear model that measures the highway versus say the engine size, which is by the cylinder, it's number of cylinders in the engine. So 4 is a smaller engine, 6 is medium, 8 is a larger engine with 8 cylinders. What I would want to do is I would want to potentially come up with different models by manufacturer. How might I do that? We need to utilize a concept called branching. And this is basically an iteration, an idea about iteration. So when I use this tar group by, and I give it, again, I just give it a name. So the name is what shows up here in your like target visualization network. The command, I'm going to basically say, all right, take this target here, which is the output, this data frame, and then I'm going to group it by this group manufacturer. So we're going to, this is the beginning stages of producing a model by group. So if I run tar make again, now what it's doing is it's rerunning the steps that I need to run. And if I do the tar viz network, it's created this grouped MPG here. And I can actually check that out again with the tar read function. So now I see that there's manufacturers, 15 groups, and there's also this new column called tar underscore group. And what's cool is, and I'm not sure if we can do it with this one, if I do branches equals 1.
So this is, yeah, so this is not branched quite yet, but it's preparing. Gotcha. It's with tar group by, you were preparing this target for dynamic branching targets that depend on it.
Gotcha.
So, this is telling how any dynamic branching target will need to slice the upstream dependencies.
Right. Okay, cool. So that explains why I got the same thing back with branches equals to 1. So we still see all 15 manufacturers. And what I was expecting was just a slice of that data, which would be the first manufacturer, which would be Audi. So what is interesting here then, so this sets you up. This is like your quarterback, right? Saying, all right, hey, I've got this play I want to run. It's 15. We're going to split off into 15 different groups. And then we're going to start doing some calculations on each of those groups. So what I'm going to do here next is utilize this tar targets. And we have a new thing, a new kind of concept that we're going to add in. And it's providing now what's called a pattern. So the pattern, all we're going to do is I'm going to take this previous step, and then I'm going to tell it that we want to run this as a pattern where we just extract out each of the different, basically each of the different slices. And I'm going to be calling this grouped branches. So if that doesn't make a whole lot of sense quite yet, just let me run tar make. And what I'll do here is, and we can see what it's done. It's basically building branches now. And these are just kind of like, how would you consider this? Well, it's basically what's this number here mean? Is there kind of like, what's the logic behind this?
So those are hashes to identify the branch names. So it's difficult to create friendly names for those things because we don't always have text names we can draw from upstream dependencies. And numeric indices don't make sense in a time like this because for example, if you have 10 branches and you insert one in the middle, then all the branches with greater indices are going to change names, and that would invalidate all those branches. And so the hash system allows you to, let's say if you insert a branch into a dynamic branching workflow, it allows only one of those targets to run and the others to be skipped, because the names are completely independent of one another.
Gotcha. So you're basically coming up with unique names now for each of these branches. So when you see that, it started and built them. And then what I'm going to do now, so I ran tar viz network without this label argument in here, but now I'm going to add in branches. And when I run this, what's cool here is it'll give you the number of branches. So there's 15 different branches, one of these for each of the auto manufacturers. And what this will allow us to do then is kind of take it to the next step, which since this has branches to it, if I take a look at my grouped branches here, so if I do tar underscore read, and if I do grouped underscore branches, and if I set branches equal to 1, control enter, now what it's doing is it's just pulling in the data, that slice that's unique to that specific branch. So if what this allows me to do is be able to do iteration now in the target's kind of workflow system. And this is what we call dynamic branching. It's building these branches on a fly. So if I do branches equals 2, now this is Chevrolet. If I do branches equal 3, this is the Dodge piece of the data set, and so on. Cool. So now that we have this concept of iteration, or I should say grouping by and then splitting out the data. So we're grouping, and then we're going to be able to use this pattern called map. What this gets us is the ability to apply functions now to these different slices. So let's take this concept one more step further. And what I want to do now is I want to map an LM model in kind of a tidy-esque fashion. So what I'm going to do is I'm going to create a new step that's going to be an offshoot of this step. And remember, I've got 15 branches that are in here. That's what this square is. It's a pattern. It contains the 15 branches. So think of it like 15 different kind of spokes coming out of grouped MPG. And what I want to do is I want to map a function to it. So this is the function. It looks like a little bit of kind of craziness, but all it is 2 steps here. What I'm doing is I'm creating a tibble, and I'm taking my grouped branches, which is the output up here. Remember, a grouped branch, it's going to be seeing one of these slices here. So I'm grabbing the first the unique manufacturer, and I'm going to have that as a grouping variable. And then what I'm going to do is also create a model column, and that's going to be a list where I take a linear regression of highway as a function of cylinder and displacement. And the data set that I'm going to use comes from my grouped branches, which is just the output up here. So it's going to be each of these slices. And again, I'm adding this pattern here. This pattern is really important. And I'm using this map function. I'm telling it to map across the grouped branches, which is my 15 branches here. So when I do this, if I've done everything correctly, so let me save this. Let me first do the viz network. So it'll showcase before this is run yet. So I've got my LM models in here now. It's my new step. It's showing as outdated because I haven't run the tar make function yet. I run tar make, and now what it's doing is it's going through, and this is cool. See how it says it's skipping all the stuff. So these 3 steps it can skip because those are up to date, and then it's just running these LM models, and that fast. It's already produced all the LM models that I need. So if I run this tar viz network again now, and we can see it's LM models, 15 branches. So it just made 15 different linear regressions, 1 for each of the manufacturers. Okay, cool. So let's see how we can use targets. Tar read, we can check out the LM models step. And again, what I can do is actually, if I don't include the branches, if I just do all the LM models, it pulls it all in as a data frame. How cool is this? I've got a tibble now, 15 by 2, with all of my 15 linear regressions, 1 for Audi, 1 for Chevrolet, and so on. But if I do the branches, so branches equals 1, and this pulls just the specific one back. So think of this as like it will either combine if you leave out the branches. Or if you want a specific branch, you can specify that. So if I want like the Chevrolet, it would be number 2. Oops, that was the wrong one. It should be this one. So this is Chevrolet. This is the linear model that refers to Chevrolet. And then I can even do cool things like I can pull the LM model, Control Enter, why didn't that work?
I believe the column name is mod.
Oh, mod. There we go. Yep, you're right. And you can see like the actual call to the specific model for the Chevrolet. So pretty cool. Thanks for that, Will. Appreciate it. Yeah, debugging live is a lot of fun.
Yeah, it's easier from where I'm sitting.
Right.
Another fun fact in tar read is actually now that I'm mentioning that is you don't actually need quotes for tar read. It quotes the symbol you apply to the first argument.
Oh, okay. And, so I can just do LM models here, right?
Yep.
Okay. Yeah. And yeah. All right. Cool. So I can leave this quoted or unquoted, and it provides the same result. Mm-hmm. All right. Sweet. I did not know that. Okay. And then the next thing. So these are still branched models. And we can continue just our pattern of mapping. So I'm taking the output of LM models, which is what I named the previous step, and I'm telling it to then use this Broom tidy function. And I'm giving it this step a name of map Broom tidy. So that'll be an offshoot here. And I'm going to basically tell it to run Broom tidy on LM models mod 1. So basically like what we did back here with this pool mod, it's going to extract out that first element. And then it's going to run this function called Broom tidy. I'm also going to add a column here called tar group, and it's going to give me the tar group. So if I run this again, and if I go back up here, tar make. And let's see here. This is the next step. So if I do tar viz network, let's just quickly check it out. So this is the map Broom tidy. And what Broom Tidy does, if I check this out, this is going to read in branch number 2. So it's the Chevrolet branch. It's giving me the intercept and the coefficients now for each of the models. So cool. You can see how we're now iterating through 15 different models. And if I want all of those, I can just leave this, just run tar read without the branches. So just do this, Control Enter, and now I have it for all of the different groups. So you can see how that mapping process is now working. But what gets even better is, okay, so we've just been doing a linear workflow, but what if we want to split out even further, start to parallelize our branches? And this is cool. So we can do another function, which will be the Broom glance function. So it's the same thing that we're doing up here, but what glance does is it, instead of giving us the estimates, it gives us the accuracies. So let me just save this and I'll rerun tar make. We can see here, it's going to skip a bunch of steps. It's skipping everything. The only thing that it's building now is building these map Broom glance. And if we check out the Viz network, now we'll see that there's a split here. So these are now going in parallel steps. And we're taking the output of LM models and now running it through the Broom glance function. And we can see what it looks like. If I just do one of the branches, this is our, for tar group Audi, our R squared, adjusted R squared, and all the accuracy metrics. And if you want them for all of the models, we just take off the branches. Okay. So Control Enter, and now I have it for all of the different models. I have all of the accuracy metrics. Very cool. So now we're getting somewhere. And then the last thing here is, or I guess there's 2 more steps. We can combine these 2 results. So what I'm doing here is just binding the rows. And this is actually the same thing, but what this does is allows targets to track that, I guess. And I'm not sure that this step is necessarily 100% necessary, but it'll return just a single data frame for the output now. So if we check this out, if I rerun, if I take a look at the Viz network, now what I'm going to be doing is adding these 2 steps to combine. So think about it like splitting and combining. So right now I'm just using bind arrays to combine everything. I'm going to run tar make on it. It's going to quickly go through, skipping all the unnecessary steps, and it's already done. And now what we have is, if I just pull the combined results, it just pulls everything in as a single data frame. And then the same thing here. Okay, so if we think about this conceptually, what we've done here now is figured out a way to use this concept called branching, which allows us to iterate, right? So we're making many models for, we're splitting up a data set into many different data sets, and we're running models, just a single linear model on 15 different pieces of that data set. So that's kind of like what we need to do for time series, right? Time series gets a little bit more challenging. So we're going to go through kind of a full scale production piece here. So I'm in the O2 energy forecast. That's this file right now. And what we're going to be talking about here is we're going to take this data set that we used in lab 54, which is going to be contained in this data folder. It's this net power generation for all sectors. And it came from the EIA. This is the link here. What we're going to be doing is converting this into targets now. And we're going to go through that same style of process where we split it up into many different targets and kind of do this mapping. So I'm going to go through pretty quickly. I'm scrolling down here to the targets file, and I'm just going to grab all of this, Control C, go to my targets file, and we're going to replace this targets file now. So if I do Control V, or whoops, let me just make sure I Control V. Oh, I must not have grabbed it. So let me go back here, copy this. I'm going to paste it in here. Paste. Okay, cool. So you can see this is a much longer targets file now, and it's going to take us down through a bunch of different steps. I'm actually breaking it out too. I'm using functions now in a functions folder, which is right here. That's this functions energy analysis. And we're going to be using more packages now too. We've got tidy models, Modeltime, the tidyverse, time PK, lubricate, janitor, forecast, and profit. We're going to be basically telling targets that we need these packages as dependencies. So we'll step down through this. Let me first just run the file. I want to run tar make on it. So this is in my O2 energy forecast. I'm in the running target section. Make sure I have these libraries loaded. I'm just going to run tar make. And you can see that what it's doing is it's running through, skipping the steps that have already been previously run. So before I put this lesson together, I already ran everything. And you can see we're doing a lot of steps in here. So we're creating models, we're building a lot of things. And this is probably, as a data scientist, you're going to be doing these types of analyses where you're building multiple models, and you saw how fast that ran. These are models that might take you days to run. And this is, and what this is doing is it's now producing a report here at the end. If I take a look at my viz network, notice that I'm also adding targets only equals true. So if I take this off here, it gets pretty insane because it's going to show all the functions and everything too. So yeah, you really can't even see it because there's just so much stuff going on. But if you put targets only true, and if I label the branches as well, which is what we saw previously, what we can zoom in on here is this process where we're pulling in an energy file, or bringing in some data, cleaning it. We're splitting it up into two paths, which is kind of like what we did previously with the LM model once we got onto glance and tidy and ran certain things in parallel. Now there's a lot more complexity to this one. So let's talk about kind of what's going on and step down through it real quickly. Going back over here into my targets, I'm going to first just, I'm going to go through all the way down to extending, and then before I do the grouping. So what I'm going to do is from here down, I'm just going to comment these out, Control-Shift-C, save that real quick. I'm going to rerun my tar make, and we'll just talk about this first section of steps. So this is collecting our data. If I run the tar viz network, these are the steps that we're going to be coming through real quickly. So if I go to the targets over here, the targets file, this first step is basically pointing to, and it's just named energy file. And I'm pointing to that location of that data set. So that's that net generation, and I'm telling it's a format file. Will, can you tell me why we use format equals file here?
So targets is primarily designed to abstract away the files that are returned that are saved to storage as you run the pipeline, freeing you to think about and work with ordinary variables in R. And this is usually a good thing. Usually you have in-memory data sets, in-memory model objects, and you want targets to store these as files on its own. But there are other times where you actually begin and end with physical files, and you have to give targets special instructions to keep track of any non-standard files outside of the data store, which is what you're doing here. And all that's required is to return the path, a character vector with multiple files and or directories to the files that you want to track, and then say format equal to file in the target definition. And then targets, all it knows is that you run this command. This command returns this character vector of paths and tracks those files, the hashes, timestamps, and file sizes. And those could be input files, output files. It's entirely up to you. But it does track those file paths for changes. So if the data file changes, it's going to invalidate that target and targets downstream.
Gotcha. Okay. So it basically tracks that file then. So if anything changes with that file, meaning like the timestamp on it changes or anything, it's going to recognize that and know to rerun all the steps that data is in it. Okay.
Primarily, cool. It's based on hashes. So if you modify this, if you open the file and then or use the touch command in Linux and change the timestamp, targets is going to recompute the hash of the file, but it's not going to rerun. That target is still going to stay valid, and the relevant targets are going to be skipped. It uses timestamps and file sizes actually to try not to hash the files too often.
Gotcha.
So it uses timestamps to the extent possible where it can, up to a certain degree of precision, but it ultimately relies on the hash. And this helps because when you copy a project to a different computer, you're most likely going to have an updated set of timestamps.
Oh, nice. Okay. So basically, yeah, it's doing its tracking thing, and it's trying not to rerun unnecessarily, but it will rerun if the hashes requires it, right?
Right.
Okay, cool. And then what I'm doing in here, so that's the only difference between this branching basics. Since we're using a toy data set here with the O1, we just pulled an MPG. So we kind of like skip that step of specifying a file. But here, what we can see in our targets now is we're actually specifying a specific file location, which is pointing to the inside of this data folder, that file. Okay, once you point to that location, what I'm able to do is then read in that file here. So I'm going to use read CSV just to read that in. So I'm giving this step a name called energy data. So if I take a look back at my viewer, there it is. So I give it this step energy data, and I'm reading in that CSV. The next thing that I'm doing is I'm taking that input, so that CSV looks something like this. If I read in energy data, it's pulling in this data set, and it's in this kind of weird format. You see it's got a bunch of NAs and stuff. So what I did was I added a function called clean data. And what that's going to do is going to take this data frame, and it's going to do some pivoting operations and so on. And those are going to be in my functions here. So this clean data function, you can see here, we're cleaning data, we're pivoting data, we're doing basically all of that preparation. We're joining some data, and then we're going to return that data frame once we're done. So that's what this step does here. And when I output that step, if I do the clean energy data, so make sure if I have this, let me do this. Hold on one second. Copy this. So if I look at the clean energy data, control enter, it now looks something like this, where I've got a source key, a date, a value. So it's kind of that tidy data set appearance, right? We've got timestamps, we've got values, each row is an observation. So this is date 2001 for this specific fuel source, which is fuels, all utility, etc. So we've now formatted the data. That's the second step, clean energy. Then what we're going to do, and I teach this in my time series course, is how to extend the data set. So for each one of these time series groups, so you can see it's 4,200 rows, and there's 18 different columns in here. So what I'm going to do is I'm going to use another function in here in my functions called extend data, which is going to do a group by, a future frame, and an ungroup, and it's going to extend each of the datas, these time series groups. It's going to extend them 24 observations into the future. So that's what I'm specifying here when I do this extend data next. Horizon equals 24. It's going to take the output, this clean energy data. It's going to take that and it's going to extend it. And then I'm going to give it a name of extend energy data. So when I run extend energy data, so clean energy data was 4,267 rows. Now, if I run the extend energy data, it looks very similar, but now there's 4,458 rows. So 24 times 18, that'll be the difference. 24 time steps into the future, I've extended each of those time series. The next thing that I'm doing, we're going to then split off this into a future data set and a prepared data set. The prepared data set is what we're going to do for training and testing. And then actually that's going to be what we use for refitting as well. And then that future energy data set is what we're going to be for doing our future forecast. It's going to have a bunch of NA values in it, and that's okay. What we're primarily interested in it for is the timestamp. So if I check out those data sets, if I go back to actually my targets, the only this kind of splitting happens here. So I'm taking the extend energy data and I'm dropping the NA values. So there's going to be 24 time steps for each time series that have now NA values. I'm dropping those, and then that's basically what the prepared energy is. It's essentially the clean energy data. And then the future energy data is going to be our future frame. So let's check this out real quickly. We've got data prepared 4026 by 6. And that matches, it's actually a little bit less than the clean energy data because there must be some missing values in that data set. So we're dropping those out. And then the future energy data, you can see that this timestamp starts 2021-02-01. So that's where these timestamps end off. And you can see that there's missing values in them. And that's what we're interested in, because this is going to be the future data that we're going to want to predict. So we're going to use this data frame to predict. Okay, cool. So we've got our data now prepared. What I'm going to do is the fun part now, or what I think is really cool. We're going to be doing some of this idea of grouping and branching. So next here, let's go down and we'll just do this one down to here. And I'm going to still comment this one out. So what we're doing now is we're going to then take our data sets and we're going to start to group them. So this is that idea that we talked about with the linear model, where we made those 15 different linear models. What we want to do is we want to split these up by the time series. So we're going to use grouping columns like source key, location, fuel, and units, which is right here, to do this group by. So we're using this tar group by function. If I run this now, if I do tar make and do the tar viz network, so it's done now. And if I take a look, we should have some new targets here. So we had these future energy data sets. Now we've got them grouped, and this is kind of like that preparation, right? We're preparing it for doing iteration. When I do the branching, that's the next step. All I'm doing here, Control Shift C, is basically returning the output of the grouped energy data, but we're adding now this pattern map the grouped prepared energy data. So these have now added the groups, and now what we're doing is telling it to map across those groups and just return the individual slices, and that's what gets returned as branches, and that's why I'm naming them prepared data branched, future data branched. Okay, so if you get that idea, we'll just run this tar make again. We'll check out the tar viz network, and we should now start to see that if I zoom in on here, we now have future data 18 branches. And if I check out the future data, so let's do just real quick, tar read future data branched. And if I grab branches equals 1, so this will just grab the first slice. We've got the first slice here, 24 by 7, and you can see it's all missing values and it extends into the future. If I grab the second branch, we're now looking at a different source key here. But again, it's the same timestamps and missing values, extends into the future. And if you want to get the prepared data for each of those branches, so you would just swap it out with this prepared data branched. Control Enter, and now I've got 241, and this is what we're going to be using. See, the values are not missing, so they have values in there. That's what we're going to be using for the modeling. Okay, cool. So we're getting somewhere now. We now have our data sets branched. What I'm now going to focus on is I'm going to set the future data aside for a few minutes, and I'm going to focus on this prepared data. What we're first going to do is split this up into training and test sets. I'm going to use a split group TS data. That's another function that is just located over here. It's a split group TS. Basically, we're going to use time TK to do my time series splitting, and then we're going to return it back as a tibble with the associated target group. So when I save that, run this next section here, tar make with the tar viz network. And it's going to basically see how fast that runs now. It's splitting it up. And let's see, if we want to check out what the splits look like, this is what the splits return. We now have for all 18 of our time series different splits, but it's actually branched. So you can see if I do branches equals 1, this is just grabbing that first target group. I can do branch 2. And then if I want to actually pull out information from one of these branches, like the training data set, this is how I would get access the training data set. So it's 217. If I want the testing, I just swap this out with testing. And this is the 24 observations that I'm going to use from my test set. So basically, what we've just done now is for each one of these 18 different branches, we've now split them up, all 18 of those into training and test sets. And we've got now our training. So this is training 217 observations, and our testing is going to be 24. And this is what we're going to use to get all of our accuracy metrics. Okay. Once we do that, then it's on to modeling. So this is some fun stuff. I'm going to run this now just with the ARIMA. And when I add this one in now, I'm going to do tar make and tar viz network. And it's running down through it really quickly. I've got this now workflow fit ARIMA, and basically what that's done is it's run now this modeling workflow, which is how you use one of the ways that you use tidy models. So we're talking about integrating tidy models into this targets workflow. So how I did it was I took the tar group and I grabbed out the training data set from my splits. That's just what we saw previously. I created a workflow that adds an ARIMA, a recipe, and then it fits it to this training data. So I grab the training data from my splits. I'm now fitting a model to it, and then I'm going to return that with a little bit of meta information. So the workflow, this is the key here is a workflow. This is our model. I'm putting it into a list. I'm returning it as a tibble. And then what we can see here is when I take a look at what that looks like. So if I look at that tar read now, basically what it's done is it's taken this tar group and splits object and just added a column here for my workflow fit. And I'm now keeping all of the splits and the workflows together. And if I want to grab just one of those branches, this is the tar group 1. I now have my model that's been fitted. And then what we can do is we can do the same thing. Oops, let me go over here. We can do the same thing for profit. Control-Shift-C, save that, rerun my tar make. So we're now using, we fit 18 different ARIMA models, and now what I'm going to do is fit 18 different profit models. Now, I will say this, because I ran this previously, you're seeing that I'm skipping all of these branches. That's because I've actually run this once, and Targets now knows to skip those. And that's why this modeling exercise is going a little bit faster than it would normally if I didn't have previously created it. So I've now added my 15 profit models, and we now have, just like that, created all of the infrastructure for modeling 2 different models. And if I wanted to add another model, I could just add it in here. So you can see here, this is the profit output. I've got all 18 of my profit models now stored in a data set here. So very cool. Next, what we can do is, whoops, keep going back. I'm going to X out of this one. We don't need that anymore. I did not add a GLMNet model. I was going to add this, but I figure I'll leave it for my students as a challenge to add a GLMNet model in here. And you can then see how quick and easy it is to upgrade and add a new model. So I'm going to skip that step, and I'm going to go right to accuracy. So next, what I'm doing here is I'm going to take for each of these workflows, all 18 of these branches, I'm going to calculate the accuracies for them. So if I run tar make again, whoops, I must have left let's see, what did I do? You done comment these two lines here, Control Shift C, and that should get rid of the squiggly. And if I run tar make and then tar viz network, and this will compute my accuracies for me. So it's just using another function I have over here, which is going to take a model table, and it's basically going to pull out the workflow, and it's going to run this model time accuracy on them, and then it's going to compute the accuracies. So what ends up happening now that I have this new section here where I've just now computed the test accuracies, so this is on the out of sample data set, what we're doing is we're now able to visualize and to get our test accuracies. So if I run test accuracy ARIMA, I can see now for all 18 of my models, I now have the test accuracies that are fully tracked. These are tracked by targets, and this makes for auditing super easy. And I have the same thing for profit now too. So these are all my profit accuracies. And then what I can do is I can apply some logic now. So the next step is, okay, I need to compare these two models and see which one's doing better. So like, for example, this first one, you want to go, we'll probably want to select the one with the lowest RMSE and out of these two, and then we'll pick which one we want. Well, that's really easy to do. So if I go over here, if I go down to compare models, that's what this section of code does right here. So we're going to use a new pattern where we're going to take two branches and iterate over them. So you're seeing here, we've been previously using kind of this map pattern here with just one, but now we can map across two. And if they're the same length, we can iterate across them. So that's what we're doing here. We're mapping across the test accuracy profit and ARIMA. And we're going to use this function called compare best test accuracy. So all this function does, if I go down here to compare best test accuracy, it's going to take these two data frames, stack them on top of each other, which is what this bind rows does. It's going to group it by the tar group. So it's going to, and that's what's going to allow us to compare profit to ARIMA. And then it's going to slice the min RMSE, grab the lowest RMSE, and then just ungroup it, and it returns out basically the lowest RMSE of the bunch. And you can add as many models as you want. You just, if you would add another model, you just put a comma here and you'd add that new model, like the GLMNet that we were talking about. Okay, so if I run this, I just go back up here, run tar make. And if I check out now the accuracy, so I'm going to scroll down here. Actually, if I do the viz network first, we should see that these two get combined now. And we can see we've got still 18 branches, but we've now kind of taken the output from each of these and combined them. And if I take a look at my best models now, we should see some differences. We're seeing ARIMA for the first one. For the second group, it's ARIMA. For the third one, it's profit. And you can actually see specifically from model time which models are being selected. And these are the accuracy metrics. So once we have that, it's really just applying that logic and selecting the best models next and refitting. So we'll kind of go down through this. We're selecting the best models now. Control Shift C, and that uses this function. So we're now mapping three, and we're taking the best test accuracy. We're taking the workflow fit ARIMA and workflow fit profit. And we're going to use this function called select model to grab out the best model using this as kind of the quarterback. All right, this is, this is for the first model, we want to pull the model with this description. For the second one, we want to pull this model. For the third one, we want to pull this model. And that's what this function is going to allow us to do, this select model. It comes from right here. Select model, all we do is we just take our accuracy table and we're going to take our output of our workflows. We're going to stack them on top of each other, and we're going to add a model time description to them, and then we're going to filter out which model time descriptions match the description from our quarterback, which is our accuracy table. Okay, so that's what this next section does here. And when I run this, do tar make, tar viz network, and then if I scroll down here, we go to our, we got the best models now. So if I check this out, control enter, we now have our workflows for each of our best models. Okay, so these are the models that we've hand selected now that do the best job on each of the individual time series. Okay, the next step, we're going to do some refitting. So that's what this next piece does here in our targets. We're doing some refitting here. Control Shift C. What refitting does is we're going to take now our prepared data, which is way from back here. It is the prepared data branch. So it's this data set here. And we're going to use our models now, and we're going to refit them. Because remember, these models have only been trained on the testing data. And with forecasting, we want to train it on the full data set before we then forecast into the future. So we need to do a retraining step. That's what this refitting does. And when I run that, if I do the tar make and then tar viz network again, and while that's running, I'm going to pull up the function that it's running. So it's running this refitting operation, and we're just running model time table. We're grabbing the workflow, and we're using the refit with the data prepared. So that data prepared again comes from right here. It's our branched data set. Did it not? Let me see. Did I? Oh, I forgot to save this before I ran. Whoops. That's why it didn't pop up. We've got our best models, so we should see an offshoot from here. And if I do tar viz network, and we see now the refitted models, which is taking the data prepared here and refitting using the best models. Okay. Cool. The last couple steps here, we just have the forecasting. So we're going to, next, we're going to do a multi-map again, where we're going to use this forecast the future. We're going to take our refitted models, and we're going to take our future data branched. And what this is going to do is allow us to do our forecasting. So this is, once we're done here, we've completed our forecast. Okay, so we're done here now using the viz network. We should see one more step. Oh, I forgot to save it again. Dang it. Okay, so we're kind of going, we're pretty much wrapping up this forecast now. So we've created our models, we've selected the best models, we've then refit them, and now we have our final forecast. So let's take a look at these last few steps here. We've selected the best models, so that's what this looks like. We've then refit these, which won't look like much new because it's just a refitting. It's basically taking this workflow and refitting each of these models using the original data, which comes from this this data set here, this prepared data branched. And then what we're going to do is we're going to make a forecast with them. So that's what we're doing here. So we're reading, what I'm doing is I'm reading the forecast, and this has now made a forecasted value for each of these different time series. And if I want to prove that, I can actually run a group by and group it on the target group, which is right, oh, it's right down here. So just open this up a little bit wider. Just run these two here. So you got this tar group, I'm grouping it. We've got our 18 groups, and I'm grouping by tar group in the fuel. And then I'm just going to use this plot model time forecast, and we can actually visualize what we've come through. So you can see here that we've made the forecast now, and we're just visualizing it with this plot model time forecast. The final thing is if we want to just read one specific branch of this, it's still branched. So we can run this. And the only thing that's changed is I'm running branches equals 1 here. And if I swap it out with 2, I can check out the forecast on the next branch and so on and see how they're performing. Then one thing too we might want to add in is I've added in some error checking. Control-Shift-C. What this does is it takes a look at some of our accuracies and it reports whether or not certain things are out of whack. So this is for, in our report, we're going to want to report some diagnostics. So let me run the tar make again and tar viz network.
At this point, I guess I'll jump in and say that I like the way that you're iterating over the targets in the pipeline, incrementally adding them and then checking them frequently. This is exactly what I recommend. Making it easier to go through the mechanics of this might be actually the RStudio add-ins that run tar make in the foreground and that run tar viz network. In the RStudio IDE, you may be able to program keyboard shortcuts for those add-ins.
Oh, okay. You mean, okay, so there's the add-ins up here. So
yeah.
If I do targets, if I just type in target. Okay. So visualize the targets pipeline. Are you talking about these things here or which?
Yeah, the visualize the target pipeline and run a targets pipeline in the foreground. If you have keyboard shortcuts for any of those, then your students who iterate over workflows in the way that you showed would maybe have a really easy and smooth time jumping back and forth between tar make and tar viz network.
Okay.
And things like that.
Gotcha. So does this basically just, okay, so it runs the current R process. Okay. So is it okay to go ahead and just select it right now?
Sure. Yeah.
Okay. So this is now, okay. Oh, it's just, so this is running like tar make?
Mm-hmm.
Oh, okay. All right. So as opposed to just typing in the tar make, is that basically what it replicates?
That's what it does.
Gotcha. Okay, cool. There we go. Learn something new. Okay. Just real quick too. The one last thing, the accuracy check. So I want to report that. This is what that last step does here. This is the accuracy check that I just added. I took a look at my best test accuracies and I'm reporting whether or not there's any issues there. So one of the things that I've added in, if I go to my functions over here, go to the check accuracy. So this function here basically looks at whether or not we've got some, it's just a simple check. If R squared is less than 0.15, I'm saying, okay, throw a message to add to our report that the R squared is less than 0.15, the prediction has low variance, which could be an indication of an issue. And then we just put that then in our audit report. The last step is then rendering the report. So I have already created a template and this is what everyone will get as the bonus. So when I run this now, it produces a report. So tar make, tar viz network, while those run, I'm going to basically go to my files here and it'll take a second to run. Okay, got the viz network. It produces my report now. So if I go to my reports over here, this is the template it uses and this is the report that it generates. So if I view it in the web browser, it looks something like this, where it just takes kind of the results of everything we've been doing, makes the visual of our forecasts, makes our accuracy table, which is all tracked by targets, and it produces any possible errors. So tar group 5 had an R squared of less than 0.15. I take a look at, this is the fifth one here. You know, you can zoom in on it and kind of see what was happening. The key here is that it had a big drop. So that's why that R squared value was likely not very good, because the test data set, this is the test data set region right here. It's the last 24 months. And there, because it had this big drop that is not consistent with the rest of the series, that model probably wasn't able to pick it up. So that's why that happened. But when I look at this series here, it looks like the forecast is still kind of in line with the trend and picking up some of that kind of variation pretty well. So I'm not as concerned. Okay, so that's how targets works, and we saw like pretty in-depth tutorial here. So hopefully you enjoyed it. I will real quick, for those that are still sticking around, we're going to answer some questions. I also have a special bonus. So if you guys saw what you learned here and you want to take it to the next step, you should definitely check out Learning Labs Pro. If depending on kind of where you're at in your career, and I will tell you this, when I started learning data science, I was more on this end for a long time, probably way too long. And what I want to do is I want to help assist you in your transformation. So Learning Labs Pro is one of the products that I offer. I'm also going to talk about the courses real briefly. So Learning Labs Pro is, if you already know Tidyverse, Shiny, machine learning already, then Learning Labs Pro is ideal for you because it'll give you kind of new, every 2 weeks, new 1 hour lessons, just like what you saw today, where we take kind of these advanced techniques that are outside of my core curriculum. So things like targets, or like some of these tidy models extensions that we did. We're doing targets pipelines right now. We're also going to be talking some Bayesian, some big data upcoming. You should check out the Learning Labs Pro platform if you're interested in that. And I'm going to put a link in the chat, copying that in right now. Check it out. If you are more at the beginner stage, and that's perfectly okay. So what if you're interested in learning R, Tidyverse, Tidy Models, Shiny, these tools and techniques much deeper? Then I offer a program called the R track. So if you think of your kind of your data science career as a progression, right? You've got a beginning, and then how I get you up to speed as quickly as possible to expert is by doing business projects and building applications. And that's what this R track is for. What we saw today is part of the Learning Labs Pro. That's more on this end. So once you already know some of these foundational skills, the Learning Labs Pro program tends to be a little bit better for you. The nice thing is that through Business Science University, that is our educational platform, everything is taken care of. So depending on what your needs are, we have a product for you that will help you get to that next level. So, you're probably thinking possibly, I've already tried a bunch of stuff. Well, what's going to make this program different? Number one, it gets results. So I have a track record of transformations that are building and building and building. And I love seeing these, my students succeeding. This makes me extremely happy. So this is an example of Jennifer. She got a job as a VP of Strategic Analytics by taking my program. She took the R track. She learned a ton. She applied it during her interview to get a job. So she used Rmarkdown as part of her take-home report, the same tool that you saw me demonstrating today as part of the targets pipeline, that Rmarkdown report. She used that to help her get a job. She also followed my business science problem framework, which is what I teach in my 201 course. I'll talk about that here in a second. But it's not just Jennifer. There's now amounting, many students are seeing these results, whether it's Masataki, who got a data science job at a management consulting firm. Z, he got a senior data science role, and actually he just got a new job at Amazon. I was chatting with him through LinkedIn the other day, catching up with him. And he's doing amazing things now with Amazon. He's a data scientist with them. Mahana, he's gotten 3 raises in a year. We've got Herb, who's been building Shiny apps now for a little bit, but he built his first one within 3 months of taking my programs. And then we also have Raj, who actually won the 2020 Shiny competition, and he's now, I believe, a judge as part of the 2021 competition. He's taken many of my Shiny courses. So it gets results. And how does it get results so fast? It's because it's streamlined. So I take you through a progression of courses that all work together. So this is the 5-course system. There's 5 courses. You start at the beginning with the 101, and this teaches you your foundational skills. It also teaches you skills, business reporting. That's what got Jennifer the job. That's the Rmarkdown. It teaches you visualization, how do you build the visualizations that are so key to making good reports. And then also the data science algorithms. Once you have the foundational skills, you're ready to go on to advanced things like the machine learning and the time series. So these are my 2 kind of flagship courses. On the machine learning end, you have H2O, which I teach in my 201 course. On the time series end, everything that we're doing today, I teach at a foundational level in my 203 course, which teaches you model time, time TK, and gluon TS, along with that system that I've kind of walked through today. And then there's applications. So how do you distribute your work? You use a tool called Shiny, and it's really amazing. I have 2 courses, 102 and the 202, that teach you first the predictive dashboards. How do you make predictions and include them into kind of a dashboard? And then a more advanced course, which is designed for people who need to build applications that manage users within a company, and using tools like AWS, Docker, Git, and so on. That system is really amazing. It's super powerful. And if you're interested, you should definitely take a look. I'm also giving everyone 15% off today for if you join because you're part of the because you're attending our Learning Labs Pro. I'm going to put the link in the chat here real quick. So definitely check out the 5-course art track. It is the system if you are in a beginner stage and you want to, if you're struggling, if you feel like nothing's working, this is the system that will get you results. Check out the testimonials on my website. Look, there's no way other to say it than it's 100% focused on business, and it's 100% focused on getting you to the point where you can add value to your organization. So check that out. All right. Now let's take a few questions. Will, if you have a couple of minutes extra, I know we're going a little bit late on time. We've got a few Q&As in here. One attendee asked, what happens when you knit a targets file, or you knit an Rmarkdown file? Do you have any?
So there are a couple ways I could answer this question. So the primary way that targets interacts with Rmarkdown is the way that you demonstrated, Matt, where you have the tar render function in Tarchetypes that make sure that the report that you want to build, or multiple reports if you want multiple tar render calls, will render the document as part of the pipeline in a way that depends on upstream targets in that pipeline. So a report will have calls to tar read and tar load to reference upstream targets, and then automatically re-render when those upstream dependencies change. That's one way. If you actually knit that document in the RStudio IDE, you can do that to edit your descriptions, to edit prose and things like that. And that'll work just fine as long as those targets are available in the data store. And I mean, all the time when I'm working in our Markdown reports in the targets pipeline, I go back and forth between running it officially as part of the pipeline and editing it interactively and running it interactively. Both of those are possible.
Yeah, the way I was using it actually in this lesson was parameterized Rmarkdown. So that's kind of handy, because then you can just take the output of your targets file and push these in as inputs to your Rmarkdown file, and your Rmarkdown will recognize these as parameters. But the downside is if you just try and click the knit button, you might get some errors because these, I didn't set up any sort of connection to the targets data store. So what I believe you were just saying, Will, at least one of the methods is, instead of doing it this way, we can actually use targets and do the tar read. Is that right? Yeah. And just add that to our Markdown document, and then it'll read it. The downside is you would actually have to, well, I guess you could just run Rmarkdown and the Rmarkdown function to render, and you could render a report. The nice thing that I like about this kind of just works right in your workflow. You have tar render, and it just runs and renders your report for you.
Yeah, both ways are great, and they're equivalent if you have good workable default or markdown parameters.
Right. Okay, so Vignesh, he asks, would you be able to add this to the high performance time series course as a bonus? And let me think about that. I may end up doing that just because this is a nice addition, I think, to showcasing what you can do with time series. So let me think about that. A cache. What kind of checkpoints are considered in targets to skip? For example, in Luigi, it checks the output of the task as a checkpoint to consider as it's completed and skip it. Do you have any ideas there? Any comments on that, Will?
That's a great question. What targets does is it takes care of the decision to skip or to run a target automatically. Usually you don't really have to think about those things, but understanding that helps leverage targets to your advantage. So when the pipeline reaches a target, it will ask, okay, did the upstream dependencies change? Did the global objects and functions that you defined, and did the values of any upstream target dependencies change? That's another thing. Did the actual, if the target was run last time and it has output in the data store, was that output it changed or corrupted somehow? So if you go and delete a file from the data store accidentally, targets will automatically rerun a target to prepare what's already in storage. It will also check the R command that you wrote in the target. It will check the dynamic branching structure. If you have it, that'll create a different set of conditions. If you change that, it'll check the storage format. So if you have a large, so Matt, you mentioned format equal to file. There are also other storage formats to store large data sets more efficiently. So there are arrow formats like Feather and Parquet, and there's an FST format for storing large data frames. If you change any of those formats, then that will queue a rerun of that target. And there are a bunch more. So this is explained in the documentation of the tar queue function, build queues for targets. And you can activate or suppress many of these rules using the tar queue function and the queue argument of the tar target function.
Nice. Yeah, I mean, you have put a ton of logic and thought. I mean, just hearing you talk about how this is designed and how many different things that it checks. It's just, man, more power to you. I'm glad you put this together. That's all I can say. All right, next question. Mohammed asks, hi, Matt, what if we have different seasonality for each group? Can we have different models with different seasonalities? Thanks for the great lab. Okay, great question, Mohammed. So if we have different seasonalities for each group, how I tend to, so it depends on what modeling algorithm you're using. So if you're using like Profit or Auto ARIMA, which is what we use in the lab, those algorithms are automated and they can detect, what frequency you're using. If it's a quarterly frequency or if it's a daily or something like that, they're going to detect those. Now, will they do a good job with it? It depends. So the key here, I think, is that you can try it, but you should always check your accuracy measurements and just make sure that you're actually getting good results. And if you follow the same workflow that we use in this lab, it's going to take you right there. In fact, if you get low R squared, and we added that to the report, and it's going to flag those if it doesn't do a good job. So at the end of the day, trust the accuracy measurements and trust the visualizations. Those two, that's how I would recommend. And there's no real thing that says, hey, it's going to work or it's not going to work. You just have to experiment and you have to do it and see what happens. All right, next question. Arun Kumar has asked, how do I use SparklyR with targets? Should I create a Spark connection on each of the tar targets? Do you have any comments on that, Will?
Yeah, so this gets into the general issue of databases, and database practices aren't always obvious, but there are some good techniques to do this. I recommend writing when you pull from a SparklyR database or have a SparklyR connection or a connection to some kind of database. I recommend within that target having calling a function similar to the pattern that you did today, Matt. And at the beginning of that function, I remember I recommend establishing a connection to the database and using the onExit function to then tear down that connection when that function exits. And so you have a transient connection to the database, and the rest of that function that gets called from a target will be able to operate on that data. So it's very much a within target kind of operation. Sometimes it may be tempting to set a connection object as a target and then pass it from target to target. The problem is that those are transient objects that aren't really valid when you save them and then read them from storage again, and then aren't valid across different parallel processes. They're what Henrik Bengtsson calls unexportable R objects. And it's best to keep those, to create and tear down those objects within an individual target.
Yeah, generally with databases, and this is kind of, think of Spark as a connection. Connect to it, disconnect as quickly as possible, and do the, obviously do the operations that you need to do, but then you need to think about it like, is that connection going to persist? It's not going to persist. So you definitely want to disconnect. So good answer, Will. I appreciate that. Tomas has asked, speaking about TAR-Q, can you set up a heavy SQL query to run in Q? Usually there is an issue with database disconnected down, and R is really hard to track the query actually runs, whether or not it's actually running successfully. So I think this kind of gets to what you were just talking about, Will. Building it and then tearing it down, or connecting and then disconnecting as quickly as possible. Is that what your thoughts are?
Yeah, I think that's my general advice for that question. I guess I should also clarify that the tar-q function that I mentioned a couple of questions ago is actually, the Q is spelled C-U-E, as in that's your Q to start. So there may be just because I didn't write down my answer to the question. Those words sound the same, so there may have been a little confusion there.
TAR-Q.
Yes, CUE. But the original question about sort of database connections and SQL stuff, all that advice, yeah, I recommend initializing the database and tearing down. Within a target, on a target by target basis. And it is a pattern. I've heard reports of people using SQL queries either through dbplyr or through just SQL text, and that's a successful pattern.
Good. Yeah, it's definitely possible. Akash is the last one here, I believe. Is automated scheduling in the pipeline for development for targets?
Automated scheduling, so cron-like scheduling, meaning run on a timer.
That's what this question sounds like. So I think some of these other packages, I believe like Airflow and others, they do have some sort of automated scheduling systems. Although I'll be honest, I am a little bit, I haven't investigated them as much.
Well, I am exploring with the help of folks from RStudio and others in the community, I am exploring how targets fits into the RStudio Connect ecosystem, some solutions engineers I've been in contact with at RStudio are working on this a bit more heavily than I am actually, from how to deploy to Connect, how to take advantage of the Rmarkdown scheduling features in Connect to leverage the cron-like capabilities of that service. So I don't plan to build anything into targets specifically, but I think that targets won't interfere with any scheduling utility that exists on top of that.
Yeah, I think too, you can always combine targets with something else. So like, for example, R has the cron R package or the Windows scheduler, task scheduler. you could probably schedule targets to run periodically, and then it'll just automatically do what you want it to do.
Yeah.
So that's always another option. It doesn't need to be one size fits all for everything. And honestly, that can be a kind of a recipe for disaster. If you get too big in scope, and I know targets is already getting probably pretty big in scope as well. But I like what you're doing too, is you're branching off and building different packages that solve different problems, like the stand targets and the Tarchetypes. I really like the Tarchetypes.
Thank you. Yeah, that's the goal, to have this be a separable part of the functionality that can stay pure and that can stay related to just the core pipeline infrastructure, and then most of the interfaces that can be added on in separate packages. There are a couple things I'm planning. Like I'm planning as suggested by the community. I'm in the implementation phase of what I'm calling target markdown, which is going to help prototyping and pipeline construction entirely within an Rmarkdown document without you having to write a targets.r file manually or function scripts manually. So that is in the works, and that's something I'm planning to build into targets itself. But usually for these sorts of things, I'd like to do in separate packages.
Okay. Well, I have a question for you, Will. What did you think of seeing Modeltime and Tidy models inside of targets? And do you think that there is some potential there for a collaboration down the road, either with Modeltime or with Tidy models? What are you thinking?
I love it. I love what I saw today, and it answers some of my questions actually about how tidy models and targets could work together. Originally, I thought the tidy models idea of a workflow is a bit different than my idea of a workflow. They're both equally valid. But I was initially concerned, is there going to be any conflict there? Am I going to step on the toes of the tidy models developers? And it looks like no. It looks like you have workflows that exist within targets, and things work out really cleanly and nicely. And the pipeline that you put together was super crisp and idiomatic, and I think that there's a lot of potential there, and especially because if a lot of forecasting exercises behave the same way, you said, this is what a business does. This is a business problem. I can imagine a target factory that sets up all these targets, and maybe a report that accepts different kinds of data, different variations on data, but apply, and maybe different choices of models, but sets up all the infrastructure to define each specific target and the function code behind that specific target automatically. So you just have a targets.r file that calls the target factory, and maybe have arguments to select the models you want and the data you want, but then it could go through that process automatically. And I've been doing a similar thing with stand targets, where you only have to supply a stand model and a function to generate the data. And then it goes through a simulation-based validation exercise to generate data, let's say from the prior predictive distribution. If you define a model like that, it generates hundreds or thousands of replicates of that data set, and it shows you, okay, how well does the model recapture the parameters? And you can do that in a single call to a target factory. And I think that based on what I've seen today, if this is a common enough business exercise, then it would be worth creating a target factory to wrap up what you've just described today. And I have some contributing guidance about how to create your own target factories. I will link the contributing guide for this in the chat. There's so this is a link to some advice about creating your own what I'm calling packages in the R Targetopia, the system of packages that extends targets. And there's a little bit of metaprogramming involved, and there's a little bit of package development involved. But once you get the hang of that, then it's straightforward. And I found it to be a successful pattern for Bayesian workflows.
Yeah, I would say definitely there is, there is definitely parts of the process, a lot of the process, especially like the high level workflow that could probably be wrapped up into some sort of targets infrastructure, especially with model time, because with time series, you do end up coming through a lot of the same steps. There are a few kind of like gotchas though that you can run into, especially with the data preparation. And depending on, if you're trying to do global models versus local models, those will have different ways to be handled. And if you add like lags and those types of things to the data pre-processing, so we'd have to figure out kind of spots there where you can still have enough, like you don't want to over automate it. And that's always the fear that I have with some of these automated solutions. But I think though there's a lot of boilerplate stuff that could probably be, because that targets. I mean, it took me probably a day, a solid half a day to put that together. So if we could wrap that up, I mean, that to me would save people a lot of time producing an automated report. Something simple that looks for issues in your data, issues with your with your forecasts and things to watch out for. That can be super useful.
Yeah, certainly not everything is can be encapsulated as you rightly stated. So, but the things that can't be encapsulated are often some of the easiest things. Mm-hmm. Like in the case of stand targets, for example, the function to simulate a data set from a Bayesian model, easiest part of that workflow. Sometimes it's not trivial depending on the hierarchical model you're planning, but it's certainly easier than thinking about the steps of the workflow yourself, putting them together, and then troubleshooting if you didn't align, if you didn't connect your targets properly, or what have you. So only having to think about the smallest, easiest parts of that, which are usually the most flexible parts, can work out great. So maybe we require an upstream target to have the pre-processed data, and then maybe all the modeling is automated with just name your choice of model, name your lag settings, and things like that, flattening that out into some nice user-defined common arguments. And then the reporting could all be templated. The reporting is something I iterate on a lot too. But if you just know that there are things you're always going to want to communicate, then that can be wrapped up as well.
Nice. Yeah. Cool. Well, it definitely seems like there's a lot of potential, and I'm excited to explore it more. And great job with everything that you've been doing with targets. Once again, thank you so much for hopping on here today. Your input's been invaluable, so I really appreciate it, Will, and you're welcome back anytime.
Thank you so much for having me. It's been a pleasure to be here, and it's exciting to see what you're working on. I love what you've done with it.
I appreciate it. All right. Well, I will catch everyone in another 2 weeks. And I look forward to talking about the next. We have a new series that we're going to be kicking off, and I'll have more information on it. So check out the emails that I send out, and we'll talk about what's coming next soon. All right. Until then, I'll see you guys. Have a great day. And we'll see you in 2 weeks.